Hello. Hello, everyone. Okay. Look at a few people here. Well, Merry Christmas to everyone. If you're celebrating. Okay, and can you hear me? Type 1 if you can hear me. There's only 7 of you for now. Okay, perfect. Do you have any questions before we start? Maybe some comments. How do you find the last assignment? Which one was more difficult, physics or maths? Physics, okay. Maths more difficult, okay. Oh, maths was challenging, physics was as well, but I think maths was specifically challenging for those who haven't done differentiation yet. All right. Okay, so today we focus on the new assignment, the one that was published today, and it is on integration. So integration is the opposite of differentiation. Yeah, so the previous one was differentiation. Now we have integration. I need to spotlight me. Okay, so everyone can see me now. Right. Okay, so let's start. I've got 8 questions prepared for you. Nothing out of the blue. So I'll share my screen and let's get to it, unless there are more questions. Okay. So I'll share my screen. Please let me know if you can't see my screen. So tell me that if you can't see my screen. Otherwise, I assume you can all see my screen. Okay. Right, brilliant. So the first question, it is on integration, of course. It's about finding the primitive function, which is also known as the antiderivative function. So what is an antiderivative function? Well, if you have a function f of x, then the antiderivative function to that is f capital of x, such that f prime x is equal to f of x. That's the f of x. So basically, you're looking for a function whose derivative is the given function. Okay. So, and this is a nice example. F stripe of x is equal to that. Find f of x if the graph of f of x passes through the point 3, 0. Okay, so what do we do? Well, we need to find the antiderivative of that function. So we know the derivative, we need to find the primitive function or the antiderivative. So to find f of x, we need to integrate this function. We need to find the integral of minus 3x plus 12 dx. Okay, and well, that's not a very difficult integral. You know that the integral of x to the power n is x to the power n plus 1 over n plus 1. Yeah, so the standard result is the integral of x to the power n is x to the power n plus 1 over n plus 1 plus c, where c is an arbitrary constant. So in this case, it's minus 3x squared over 2 plus 12x plus c. Okay. But there's a second piece of information that is given to us, that the graph of f of x passes through the point 3, 0. That simply means that f of 3 is 0. So we have f. Okay, so let's substitute 3 into the function. It's going to be minus 3 multiplied by 3 squared over 2 plus 12 multiplied by 3 plus c, and this thing is equal to 0. So we can find c from here. So c is equal to, so this is 27 over 2, so that's minus, so plus 27 over 2, minus 12 times 3 is 36. So that is equal to negative 45 over 2. And finally, we find the function f of x is equal to minus 3 over 2 x squared plus 12x plus c, which is negative 45 over 2. 45 over 2. And this is the answer. This is the solution. Is there a line equation for a quadratic curve which is similar? That's a good question. Well, if you have if you know the zeros of the quadratic, so for example, if you have a quadratic curve and you know the zeros, so x1 and x2, if you know where it intersects the x-axis, you can write that y is equal to a x minus x1 x minus x2. That's the closest thing I can think of immediately, but not for so basically a plays the role of the gradient in this case, so somewhat similar, but not an exact formula. Okay, so let's just touch base here. So how well do you understand question 1 on a scale of 1 to 10? 10 being I understand it very well. Okay, all right. So we've established that most of you understand it quite well. So I can expand a little here. So what I wanted to expand is I wanted to kind of justify in a fancy-ish way why this is true. Why this is true. I'm just going to use a different notation here. So I'm going to write f. We know f stripe of x is equal to minus 3x plus 12. But we know that this is df over dx. And it's equal to minus 3x plus 12. So I multiply both sides. I multiply both sides by dx, and yes, you can do that with differentials. Unfortunately, we don't teach you differentials until you get into university. So I won't be able to explain why you're allowed to do that, but dx is called the differential of x, and you're allowed to multiply by dx. Multiply by dx, and you get df is minus 3x plus 12 multiplied by dx. Okay, I'm omitting the brackets here, but obviously I have them. They're there. Okay, I'll keep them for now. And then we do something that where we integrate. We integrate both sides. We put an integral on both sides. And if you look closely to the integral on the left, well, that's equivalent to the integral of dx. It's just with a different variable. F is the variable. So dx, so it's 1 dx, and the integral of that is x plus c. So in a similar way, the integral of df is going to be f plus c. We are omitting the c because we will have the c on the right, so we don't need two c's on the left and on the right. So that is why f is in fact equal to minus 3x plus 12 dx. Okay, so this integral is equal to f, or just f of x, simply speaking, and that is why I am able to do that. I'm able to write this. Okay, so that, I think I should put the arrow the other way. Okay. All right. I hope that makes sense. Anyways, moving on. F strife of x is equal to 7x minus 2, and g strife of x is equal to f of x. Find g of x. So it looks a bit complicated, but let's try to unravel this. Well, they told us that g strife of x is f of x. So I think we should start by finding f of x. So, okay, so if f strife of x is equal to 7x minus 2, that means that f of x is the integral of 7x minus 2 dx. This is a simple integral. It's going to be 7 over 2x squared minus 2x plus c. Okay, plus c, and we can find c. Okay, so they told us that f of 1 is 10. Okay, we're going to use that. F of 1 is 7 over 2 times 1 squared minus 2 plus c, and this is equal to 10. So we can find c. C is, what is it? 17 over 2. 17 over 2. So it's c is 12 minus 7 over 2, so 24 over 2 minus 7 over 2, 17 over 2. Okay. And that means that f of x is 7 over 2 x squared minus 2x plus 17 over 2. So we found f of x. Now we need to find g of x. Well, they told us that g strife of x is in fact f of x. So it's that thing that we just found. So 7 over 2x squared minus 2x plus 17 over 2. So g of x is the integral of that. Just going to be a bit lazy here. Integral of that dx is equal to So it's 7x cubed over 6, because there's a 3. 3 joins the 2, it becomes a 6, minus x squared plus 17 over 2x and plus, now I want to use c, but I've already used c. So a good practice would be to use c1. So it's a different c, of course. Different c. And we know that g of 1 is 12. So g of 1 is 12. That means that 7 over 6 times 1 cubed minus 1 plus 17 over 2 plus c1 equal to 12. And I won't bore you with the details. C1 is going to be equal to 10 over 3. Okay, you can check yourself. And finally, we get g of x, which is the answer to this question. 7 over 6 x cubed minus x squared plus 17 over 2 x plus 10 over 3. And this is the answer. Okay. Any questions here? Any questions? And the same question, how well do you understand this question? Give me a from 1 to 10. Oh, advanced. Good. Very nice. Okay, same distribution. Good. Okay. Problem 3. Well, it's sort of similar. It's sort of similar. I'll just go quickly through that. So you're given a function. Find the primitive function, f of x, f capital of x, given that the graphs intersect at a point which is on the y-axis. So what does that mean? Well, if you have a function, f of x, let's say we have some sort of function, f of x and we have a function f capital of x. Now it's going to be something like this. You could use a double integral. Yeah, you could say that, well, g strife is f of x and f strife. So basically that means that g double strife of x is equal to 7x minus 2. Yeah, and then work from there. You can say g of x is the double integral 7x minus 2 dx. You could do that. So basically, well, yeah, I can't imagine at this moment how the other function looks like, but let's say it looks like this. Now this is f of x, but look, we have multiple f of x because if f of x is a primitive function, then f of x plus c is also a primitive function. So basically what that means that if we shift the formula up or down, it's also the antiderivative. I'll shift like this. These are all antiderivatives with different c's. Okay, and finally, we need the antiderivative that goes through this specific point. So we need the antiderivative that goes through this one, because they intersect at this point. And that simply means that f of 0 means f of 0. Okay. So this is f of x plus c1. This is f of x plus c2. Just different c's. I hope you understand that. F of x plus c3, etc. It's we call it a family of primitive functions, because every function is a primitive function to the original function. Okay, so what do we need? We need to find the primitive function. So f of x is the integral of 2 sine 5x plus square root of x, which is x to the power half, plus 3/5 dx. So the interesting integral here is this one. So let's write it down separately. So the integral of 2 sine 5x dx. So we can take the 2 out. Sine 5x dx. But then we have the important result, because we know that the integral of f of ax plus b dx, sorry, f x f is equal to the antiderivative of ax plus b plus c times, sorry, I'm just going to play a trick here, 1 over a, like this. This is a very important result that you need to be able to use. And that means that the integral of sine 5x is in fact, so is 1/5 cosine 5x with a minus. So minus 1/5 cosine 5x plus c. Apologies. Okay, so we know this result, and we're going to use that here. We're going to use that, and okay, I'll just write it here. F of x equal to minus 2/5 cosine 5x. Now x to the power half is going to be x to the power 3 over 2 divided by 3 over 2. So when you know that when you divide by a fraction, the fraction flips around is going to be 2/3. 2/3 x to the power 3/2 plus 3/5 of x plus c. Okay, and then we know that f of 0, because x is 0, on the y-axis x is 0, is equal to f of 0. But we know f of 0 because we know f of 0 is 2 times sine 0 plus 0 plus 3/5. So it's equal to 3/5. And this allows us to find. So f of 0 is equal to minus 2/5. 2/5 times 1, because cosine of 0 is 1 times 1. Okay, I'll write this down, times 1, plus 2/3 times 0, that's 0, plus 3/5 times 0, that's 0. Okay, plus 0, plus 0, plus c is equal to 3/5. And from here, it's quite easy to deduct that c is in fact 5/5 or 1. So 2/5 plus 3/5. So c is 1. And we get the answer. The answer is f of x is equal to minus 2/5 cosine 5x plus 2/3 x 3/2 plus 3/5 x plus 1. This is the answer. It is the default notation. The f capital of x is the default notation. So if you see that, you can safely assume that it is the antiderivative. It's not the integral. F of x is not the integral. So we say that the integral of f of x dx is equal to f capital of x plus c. So f of x is known as the antiderivative function. It's a function whose derivative is f of x. Let me write this down. Just so f of x is a function whose derivative is f of x. And there are infinitely many of those functions, because adding c does not change the derivative. There are infinitely many functions in the form f of x. Okay, so hope that makes sense. All right, problem 4. Now we're moving on to definite integrals, and we need sorry, thank you. F of x plus c for any c would be the primitive function to f of x, yes, or the antiderivative. Okay. So problem 4, find the area enclosed by the curves. And well, the best thing we can do is to plot that, and we need to find that area, so we can do we can do it like this. Powerful tool. So we need this area. Okay. We need to find this area, which is enclosed by the curves y equals x plus 6 and y equals x squared. Y equals x squared and y equals x plus 6. So plotting, we can see 2 points of intersection. And we know that the area under the curve is equal to the integral between limits. Okay, so let's find the, let me copy this. It's a tad too big. So what we need to do is to find this area. There are several ways to do this, of course. The more you learn maths, the more you understand that there are several methods of doing this. And so we can find the area under the area of the trapezium. And I think this is a good point to remind you that, yeah, these are valid because this is 4, this is 9, and the height of the trapezium is 3 plus 2 is 5. So area of the trapezium is 1/2 a plus b, so 4 plus 9, multiplied by the height, which is times 5, which is plus 9 is 13, 65 over 2. 65 over 2. That's the area of the trapezium. Now we need to find the area under the curve. Area under the curve is this area. This area. And this is the integral. Now area under parabola is equal to the integral and between limits -2 and 3, because that's the limits along the x-axis, and 3, and it's x squared dx. So it's quite straightforward. So you need to, it's x cubed over 3 between limits sorry, x cubed over 3 between limits 3 and -2 and 3, and we get this, it's equal to 3 cubed over 3, which is 3 cubed 27 over 3, which is 9, minus 8, so it's going to be plus 8 thirds, and so the area that we need is the area of the trapezium, 65 over 2 minus 9 minus 8 thirds, and if I'm not mistaken, that is 125/6. Should be. If you find a mistake, please let me know. So that's that. Now, you could do it in a different way. Instead of finding the parabola, you can say, well, I know that this graph is y equals x plus 6. Yeah, exactly. And this is y equals x squared. You could find the integral. You can find the area as the integral from -2 to 3 of the top function, which is x plus 6 minus x squared dx. This will give you x squared over 2 plus 6x minus x cubed over 3 between limits -2 and 3. And if I did my arithmetics correctly, this is also 125 over 6. Better respect. Could you, although more difficult, with respect to dy, sorry, I'm not sure that I understand what you mean above y and less than y. Above the y-axis, above the... Oh, okay, find the left red area and the right red area separately. You could. Yeah, there's... It's all above the y-axis. Oh, sorry, above the x-axis. So it's the area is positive. When the area is above the x-axis, it is positive. To the left and to the right of the y-axis, it doesn't make any difference. It's still positive area. But indeed, if you find the area underneath, it will be negative. So you're saying y-axis, but you probably mean x-axis. An important consequence, an important consequence of this. So because if you have, we know that the integral, the definite integral, is the area under the curve. Oh yes, you could do the integral in terms of dy, of course. It's, if you want, you need a function of x in terms of y. I don't think I need to show that here. So back to this. So if you have a function f of x, the area under the function, the area under the graph, sorry, is the integral. But if you choose another point C here, I mean, that means this area plus this area would still equal to the original area. So quite an obvious consequence that the integral f of x dx between a and b is equal to the integral between A and C plus the integral between C and B. C and B. So basically, if you take two integrals from A to C and from C to B, it will be the same as you take one integral from A to B. And funnily enough, this works even if C is not between A and B. The maths works out, although the meaning kind of fades away. Okay, so moving on. Number 5. It's a very interesting one. It definitely looks unusual. But let's try to analyze what do we see here. So it's a derivative of an integral. Well, if they have the same variable, if you had dt here, then the task would be super easy, because d of dt is the integral of some sort of function of t dt. Because the integral is the antiderivative, and the derivative is the anti-integral, then the integral and the derivative cancel each other out and you get f of t. It's super easy. So all you need is just to copy the integrand. But that's not the case here, because here we have dx and here we have dt. So what we do is we copy the integral. We copy the integral separately. And let's see what's actually going on here. Well, the integral is in terms of dx. So the variable is dx. So t is not a variable. T is a constant. So this integral is equivalent to an integral like this. So I don't know, if I put, instead of t squared, I put c, a constant. So you treat t as a constant. And let's do this integral first. This is going to be x cubed plus cx. And then you do the limits. So this is from 0 to 3t, and you substitute. Yes, thank you so much. X cubed over 3, of course. X cubed over 3. Thank you for paying attention. So we do the same thing here. So nothing's changed. So it's going to be x cubed over 3 plus t squared x in between limits from 0 to 3t. And that is, so we plug in 3t instead of x. So it's going to be 27t cubed over 3 plus t squared times 3t. So it's 3t squared. 3t cubed, sorry. No, you can't do that. You can't put the d over dt into the integral. Because what do you do with the x squared? If you try to differentiate the x squared, it will turn to 0. So not really. Only if you treat x as a function of t, but nobody said that x is a function of t. So yeah, and here, so 27x cubed, so that's 9t squared plus 3t squared. That's in fact 12t cubed. And then you just need to find the derivative of that. So from here you can find d over dx, or sorry, d over dt of 12t cubed, and that is simply 36t squared, and that is the answer. A constant. If you treat it as a constant, as I said, x squared will turn to 0, and you'll just lose it. So it's going to be 2t squared. Yeah. Anyways, moving on. Problem 6. So problem 6 is integration by parts. So if you have done integration by parts, if you have ever done integration by parts, type 1. If you've never done integration by parts, type 0, please. Okay, well, okay, a small fraction of you have done. Integration by parts allows you to find integrals where you normally have a product of two functions, like somewhat similar to the product rule, but it's not the product rule. It is a consequence of the product rule, but we don't have a product rule like we do in differentiation. In differentiation is an algorithm. If you know the algorithm, you can differentiate any function if a derivative exists. If a derivative exists, you can find it. With integration, it's not that simple. So the formula for integration by parts looks like this. Dx now the proof of this formula is in the assignment, so I won't do that here. Dx. So what does that mean? Well, you need to figure out which is which is which in here. And u and v are functions of x, of course. And well, looking at this, well, let's try. Let's say u is x squared. The next one is v strife. So we don't know v, but what we do know is that we can find u strife. U strife is 2x. And we know that v prime is sine x. Sine x. So if v prime is sine x, what is v? Somebody help me with that? If the derivative of v is sine x, what is v? Minus cos x. Yeah, of course. So you begin by drawing this out. Excellent. And then you just use the formula. So this is u, this is v prime. So we just continue with uv. So u is x squared. V is minus cos x. So take the minus here. Cos x minus the integral of u prime, which is 2x, times v, which is minus cos x. So again, minus cos x, cos x dx, and the minus comes, okay, you know what, I'll leave the minus here just for the sake of it, and that is equal to something. It's a bit difficult to carry this whole expression around, so I'm just going to write out this integral. I'm just going to write out this integral separately. So I just draw an arrow here. Draw this integral separately, and without obviously. Okay, I don't want to confuse you here. So what I'll do is I'll carry on. Just do I'll just do the extra step of here. What I'm going to do is I'm going to turn this into a plus and remove the unnecessary cos x. Okay. So here, once again, cos x. And I'll take the 2 out. I'll remove the 2 because you can always take the 2 out. The 2 comes out. It's a big 2. Okay. 2 comes out. So I'm just going to deal with this separately. And this is another integration by parts. And in a very similar way, I write down u is equal to x, v is equal to something, which we don't know yet. So I can find u prime. U prime is 1, is the derivative of x. And we know that v prime is cos x. And we can find, if v prime is cos x, what is v? What is v? Yes, thank you. Sine x. Sine x. And we use the same formula. It's uv, so it's x sine x minus the integral of 1, which is u prime, multiplied by v, which is sine x dx. Now this integral we know how to do. It's just the integral of sine x, which is minus cos x. There's going to be x sine x. So the integral of sine is minus cos. So minus minus make plus. So plus cos x and plus c. Once you've finished integrating, you write down plus c. and you get the final answer. Well, it's going to be x squared minus x squared cos x plus x sine x plus cos x plus c. This is the answer. Okay, on a scale of 1 to 10, how do you understand problem number 7? First, problem number 6. Okay, that's good, especially those of you who haven't done this. That is very good to hear. Thank you. The 2 has been lost. Funnily enough, I lost it in the draft that I was making for this webinar. Or maybe not funny, but very, very sad. Okay. The next one. So the 2, which is here, it just carries on here, becomes here. Problem 7. Find the integral by 2 methods, using identities or by using substitution. So I believe if you haven't done integration by parts, you probably haven't done substitution yet. And that's why I will guide you slowly through that. So by using trig identities, well, sine x cos x can be written as a half sine 2x. We know that because 2 sine x cos x is sine 2x. I hope that was drilled in, you drilled that in the second assignment. Therefore, the integral becomes way simpler. It becomes the integral of 1/2 sine 2x dx between limits 0 and pi over 2. Pi over 2. And remember the rule that we have, if we have sine of a linear binomial, so sine of a binomial, sine 2x, it becomes half cos 2x. So it's going to be minus a quarter cos 2x. 2x between limits 0 and pi over 2, 0 and pi over 2, pi over 2. So we substitute pi over 2 first. It's going to be minus a quarter cos. Now pi over 2 times 2 is pi, and then minus a quarter cos 0. So this cos pi is -1, so it's going to be a quarter. Minus a quarter, so it's plus a quarter, equals a half. So this is a very straightforward one. It only works because it's an easy trig identity. Some trig identities are not very nice, and you won't be able to do it like this. So by using substitution, so B. So what does a substitution mean? Well, you look at the functions and you pick one of them. Now the problem is you don't always know which one to take. Usually it's one of the functions that is present in the graph. So if you had, for example, x square root of x plus 1, your substitution would probably be x plus 1. So it probably make u is equal to x plus 1. Because then x is equal to u minus 1, so you get u minus 1 multiplied by square root of u. And this is actually much simpler to deal with, because then you can do u to the power 3 over 2 minus u 1/2. And this is easy to integrate. This is not easy to integrate. You can't really integrate that. Like, what do? You have a square root of x plus 1. It's not a power. So this is a substitution. Here, we can actually choose either one. I prefer personally to use sine x. So I'm saying u is equal to sine x. This is my substitution, sine x. I need to write the integral as well. Now, substitution is probably the most difficult method of integration. Method of integration. But some substitutions can be very simple, and sometimes substitutions are incredibly hard. So and substitution, you won't fully understand it until you've done like 100 integrals or 1,000 integrals. But so here, the rule for integration, for substitution, is that you need to substitute everything. You have sine x, that's u, okay. You have cos x, well, we'll see what we can do with that in a bit. Dx also should not be here. It also needs to be substituted for something in terms of u. And even the limits have to be substituted. So what we're going to do is we're going to write integral. Now here, I will have different limits, u1 and u2. Sine x, well, sine x is u. Cos x, well, if you're not sure what to do, just leave it as cos x. Just keep in mind that you will need to substitute it for something. You just don't know by what. Using 1 minus square root of 1 minus u squared is an option, but we have a better way. So from here, I will find the derivative of u. So du dx. The derivative of u, and the derivative of sine x is in fact cos x. And multiplying both sides by dx, I get that du is equal to cos x dx. Oh, but that looks familiar. Cos x dx. It's a nice it's a nice coincidence. Let's put it that way. But you could, if it's not clear from here, you can always say that, okay, dx is equal to du divided by cos x. And we'll substitute that in. So du, oh no, don't do that, please. Minus du over cos x. And cos x cancels out, and we need to find u1 and u2. Well, u1 is, we just substitute u, because u is sine x, x1, the bottom value is 0. So u1 is also 0. x2 is pi over 2. So u2 is sine pi over 2, which is 1. Yeah, sine pi over 2, which is 1. So the limits. So I have the integral between limits 0 and 1. Of u, so u, now cos x cancels out, so I have du. And now I have an integral with no x's. So that is my aim. We went from no u's to no x's. So no x. So we are good to go here. And all we need to is to integrate that. Well, it's going to be u squared over 2. U squared over 2 between limits 1 and 0. 1 and 0. 0 and 1. And that is equal to 1/2. Okay. Long and winding road to 1/2. But believe me that this is just to demonstrate the method. For this particular integral, you could use this. But the moment I do this, 7 to the power of 7, you can't do it. Like, I mean, potentially you could find the find cos to the power of 7x and do something about it. Okay, hope that makes sense. Yeah, if you substitute it back, you don't have to change. But why would you do that? I mean, 0 and 1 is way simpler than 0 and pi over 2. And dealing with cosines and x's, if you can just do u's. Yeah, but writing the integral with incorrect limits is technically not a good thing to do. So if you are doing that and you don't want to change the limits, just omit the limits. Just say it's u1 and u2, and then you go back to the original variable with the original limits. You're allowed to do that. Yeah, but don't write du and the limits in terms of x. That's technically not correct. Just a very bad habit. Okay, and for dessert, so the last question. So this is to do with Riemann sums, and like where does the integral come from initially? So we have a truncated cylinder, and we need to find its volume by using integration, by slicing it into multiple thin cylinders. So what we're going to do is we're going to cut it. We're going to cut the cylinder into very thin slices. So imagine the cylinder is made of pancakes. Okay. So we take one such slice. So let's take this slice here. This slice. And it has a height of delta x. And we can assume that is a cylinder because, I mean, the radius doesn't change much because it's almost flat. So the radius. So if we knew the radius at this point, we could find the volume. So the volume is the area times delta x, and area is pi r squared delta x, where r is the radius at this particular location. This is the radius. Okay, does everyone, if you understand this, type 1, please. Because if you don't understand this, we need to pause here for a bit and explain further. Okay, it's a volume of a flat, it's a volume of a cylinder. Yeah? It's not a very tall cylinder, it's a small cylinder. Now let's tilt this cone, this truncated cone, sideways and introduce a set of axes, because axes are always helpful. Okay, so we have a sideways cone and coordinate axes, which go like this. This is the x-axis. This is the y-axis. And so this is 0. This is 1. This is 4, because that's the radius of this one. That's 4, because that's this bit. And then we have this bit. This is 3 on the x-axis. And what we are going to do is we are going to take the same slice. Take the same slice here. Same slice here, delta x. And what we need to do is we need to express the radius in terms of x, but the radius is actually y. This is y. So we need an equation for this line. We need an equation for this line, and it's not a very difficult one. The equation of this line is y is equal to x plus 1. X plus 1 is the equation of this line. And because I know 2 points, I can draw a straight line and can find the gradient. So this is in fact the radius. So So the radius at any point is x plus 1. That's a very important piece of information. Okay, so now I can write down that the volume, delta V, is the volume of this cylinder, delta V. Delta V is, because it's a small cylinder, that's why I use delta, is equal to area times delta x, which is pi r squared delta x. But I know that r is equal to x plus 1. So it's going to be pi x plus 1 squared dx. Oh, sorry. Giving away. Now the total volume is equal to the sum of those cylinders. But I'd say volume is approximately equal to the sum of those cylinders because we are using the cylinders of some width. So it's the sum of these cylinders. Do you understand this expression? Do you understand this expression? How well, from on a scale of 1 to 10? Oh, very good. So Ed Francis. So we are cutting. We have many of those cylinders. We have like thousands of cylinders like this, and each cylinder has a volume of delta V, which is equal to pi x plus 1 squared delta x, and delta x is the width of the cylinder, the height of the cylinder. And then to find the total volume, we find the sum. So the volume is equal to the sum of those. Did it become clearer? So Ed and Francis. Does this clear things up? Okay, good. And if you read the material about the Riemann sums, in fact, the volume is equal to the limit as n tends to infinity. N is the number of slices. So as n tends to infinity. No, I don't want n to tends to infinity. I want delta x, the thickness of the slice, as delta x tends to 0. The thickness of the slice tends to 0 of this exact sum. Because we have from the first slice to the nth slice, of course, n will be infinitely large, because if the thickness is infinitely small, the number of slices will grow accordingly. So x plus 1 squared and delta x, and well, according to the same Riemann sums, this limit is in fact equal to the integral of pi x plus 1 squared and delta dx. So what happened? The sigma turned into the integral, and the delta turned into d. Okay. So, and of course we need the integral limits from 0 to 3. And this integral is doable. So what happened here is as delta x tends to 0, delta x becomes dx, because dx is an infinitely small value. And yeah, we replace the sum for the integral sign, and that's how Riemann sums work. Don't worry if you don't fully understand this. You can still use it, even if you don't fully understand it. Yes, so you do this, and then the integral is always quite easy. Well, I'll do the integral, of course. So the volume is equal to the integral from 0 to 3. Take the pi out, it's a constant. Integral is linear, so you're allowed to take that. You expand this, so x squared plus 2x plus 1 dx. So it's going to be pi, square brackets, x cubed over 3 plus x squared. The integral of 2x is x squared plus x between 0 and 3. You substitute 3, so it's going to be pi. So 27 over 3, so that's 9. This is plus 9. And this is plus 3. Plus 3, and that's equals to 21 pi. Well, you can confirm that by just doing it geometrically. I mean, it's not very difficult. But yeah. So yeah, that's all what I wanted to cover today. So if you might have noticed that we've given you an extra week. So this week you can have some rest, maybe. It's still Christmassy, New Year'sy time. So we've given you an extra week for the assignment. So the assignments are due on the 22nd of January. And after that, they will be every week, every 3 weeks. And the webinars are every week. Every Tuesday, we meet at the same time. Unless I specifically say that there will be no webinar or something like that. Probably I won't be able to do a webinar during February half term. So yeah. Well, enjoy. Have a fantastic new year, and I'll see you next week. You're welcome. Hope that helps. When you were combining with them, says problem. Then it's the problem 4. I'm not sure if there's an absolute rule for absolute values. In some cases you can, but I mean, in general, that won't work with no, I mean, if you replace modulus everywhere, it would still work because it will still be the same function, just with a modulus. If you take the moduli of both sides, probably not. If you definitely it will not work if you put modulus on each of those. Depends. It depends what you're looking for. If you need the total shaded area, then yes. If you have, for example, a function that goes like this, and you need the total shaded area, then you do have to take the modulus of the integrals. So a to c and c to b. You need the integral from a to c, f of x modulus plus the modulus of the integral of c to b, f of x. Yeah, hope that clears things up. Yeah, if you flip the limits, the sign changes. Technically, you could do from a to c plus from b to c. Although, like, the integral from b to c doesn't really make much sense, because the other rule is that if you have an integral from a to b, it's equal to minus the integral of b to a. You're allowed to do that, although geometrically it doesn't make much sense. All right. See you, James. You're welcome.